Hi everyone, thanks for coming. My name is Ofek Shilon and I am one of the maintainers of Compiler Explorer. And in the next half an hour I will try to get you to help you get more out of it. Compiler Explorer is a very popular tool for exploring compilers and investigating what the compiler does to your tool, that does to your source. Since you're all C++ conference attendees, there's a very good chance that you've seen it already, a few times in this conference already. Actually, let me not assume this. Who here have seen this site, Compiler Explorer? Oh, that's great. Who here have used the site? Wow, okay, that's very good news. This talk is for you. This is not an introduction talk. This is a talk that hopes to take you from users to power users of Compiler Explorer. So the most basic use of the site is to type or paste your code here and inspect the output assembly here. There are a few features that help visually associate the assembly with the source. The most obvious one is the color of the lines. The pink lines here originate from this pink line here. Also, there are red highlights. If I hover above this add here, you can see the ++ token here highlighted in red. We also have intraline association. Let it be said that we use debug info for this association. So when you're using optimized builds, this debug info can get heuristic. Take it with a grain of salt, but we display what's available. Let's take a few minutes to go over some non-obvious parts of the UI. Let's do this in screen order. This pencil here, can you see it? Let me enlarge this a bit. This pencil can rename tabs. This can get very useful if you have many source panes or many compiler panes. This is where you select the compiler that you want to inspect. The list can get large and unwieldy, so you can pop it out and get a nicer looking list. You can also search for a compiler. I think the current list is of about 1,600 of those. You can also mark favorites and have them always appear at the top of the list. This is where you type in user compiler switches, say optimization. But there are switches that we add behind your back to make the site operational. You can see all of them here. When you click this checkbox, this is the full command line that we use. Also, compile switches can get to be a hefty bit of text. When it does, I recommend you click this drop down and open the detailed compiler flags when you can edit or paste the switches line by line. While I'm here, let me emphasize another non-obvious feature. In every drop-down and in every menu, when you add a pane, you can click it, and before it appears, drag it to its desired location. Next line, here's just font size, but even here there's a small surprise. Did you know that you can scroll over it and increase or decrease the font size smoothly? Let's talk a bit about output. Compile to binary object. Let me show you what that means. Without compiling to binary object, this is the output that you'd get. This is what you'd get when you add the -s switch to your compilation. This tells the compiler to stop after emitting assembly. The process here, when compiling to binary object, is different. Here, we let the compiler go all the way to a full object file, then disassemble it using just objdump. They are similar but not identical. When compiling to a binary object, you see that the raw opcodes are available. On the other hand, when there are assembly labels, they are not visible here. Also, there are occasionally padding instructions, just NOPs, that the compiler adds after the emission of disassembly. And they're visible in this pane and not in this view. It's something to keep at the back of your heads. Occasionally, it can be useful to inspect the disassembly of a full binary. If your source includes main, you can also link to a full executable and have it disassembled. Next, filters. This is not what assembly would look like if you were to generate it yourself. If you just add -s to your compiler, to your compilation line, this is what you'd get. There's a hefty bit of logic behind the scenes that filters the noise out from this full dump. You can exercise some finer control over the filtering with this checkbox. Add new, there's a ton of views. Let me call out one that is in particular of general interest. The preprocessor is the dump, the filtered dump. It filtered STD headers. This is the filtered dump of a preprocessor. It shows your includes and your defines. It can be very useful to understand code. Some stuff is going down here below too. This is clear cache and recompile. If we have some compilation errors or otherwise compiler output, you see it by clicking this, the output pane. There's other stuff here, compiler license and fuller license, and that's enough for this. There is a wide range of settings available. Let me show a few. Well, obviously a color theme. Let me show you something from the editor setups. I don't like Minimap. Minimap is this enriched scrolled bar here. I don't like it. I usually check it off. Let's talk about automatic recompiling. By default, Compiler Explorer waits for an idle period of 2 seconds before submitting a recompilation request. You can fiddle with this period if you want it more responsive or less responsive. I personally go further and I check off the automatic recompilation feature altogether. This can get annoying if your compilations are long and you don't want them to start 10 times while you're typing. You want them to start when you're ready. So personally, I check this off, and when I'm ready, I either click recompile or just press Control Enter. Speaking of keyboard shortcuts, who here uses VS Code? How do you comment a line in VS Code? Control K, Control C. Here's something I'm not sure you knew. This works here. Uncomment. How do you uncomment? Control K, Control U. Thanks. I don't know. Control Alt arrows adds multiple cursors. This is essentially a mini VS Code online. You can click F1 and see the full list of commands and keyboard shortcuts available. Just take 30 seconds to see what is useful to you. These are not customizable. Customizing them in a browser is problematic because browsers tend to reserve or steal various shortcuts. And this is not a coincidence. The web component that we use for the editor is called Monaco Editor. This is essentially a packaging of the editor, the entire editor functionality from the VS Code repo itself. This is a component published by Microsoft that enables us to do what we do here. Okay, enough with basic functionality. Now, if you've only used Compiler Explorer the way you've seen it used in conference talks, you've probably seen limited use to such self-contained small snippets, which is nice, which is a very good way to interactively explore such snippets and language features, but we try to make it useful far beyond that. And let me show you some features that allow you to go beyond small snippets. I'll briefly mention 3 and dive into more detail in a 4th one. So one such feature is libraries. We have a rather rich set of popular C++ libraries that you can check and use as if they were part of your code. I'm not sure what I clicked. Here's a random one. What did I click? Oh, CTRE, right. You can include this non-standard header as if it was part of your project. Let's try a different one. Another thing you can do, let me reset that. You can have full CMake projects as part of Compiler Explorer. You can create an empty one from scratch by add tree IDE mode, but I recommend you don't. I recommend you go to Templates and select C++ CMake and have a more populated starting point to work from. There are multiple files here. There's a default command line and there's a default CMake lists file that you can all customize as you see fit. Another nice non-obvious thing that we do is we enable inclusion of URLs. Here I just included in this format the URL of a file that is hosted on GitHub, and I can explore it as if it was local. We download it and incorporate it into the source. If you're lucky enough to have your entire project hosted on GitHub, you can essentially just paste full source files here and just modify some includes and have it work as if you would locally. But by far the best feature to extend Compiler Explorer's usage beyond local snippets is run your own instance. This is the secret. Personally, I consider this the killer feature of Compiler Explorer. Once you have an instance that runs from your own file system, it can access everything on that file system, your sources, your headers, your libraries, even your custom compiler, if you have one. So let me show you how it's done. I won't do it live because it takes about 6 minutes the first time. You go to the Compiler Explorer. Let me enlarge that. Never mind. You go to the Compiler Explorer GitHub page. You copy the URL to clone. You clone it locally. You cd to that new clone library, and you run make. That's it. It is remarkably easy. Upon the first run, the script downloads about 1 gig of node dependencies, so it can take a short while, but next runs are substantially faster, between 30 seconds to a minute. And once the script ends, you get a clickable link here, and when you click it, you go, you end up in a self-hosted compiler explorer. This is running. This is the result of exactly this run on this machine. This is a Windows machine, and it runs from WSL, but essentially the same process goes for whichever Linux distro you're using. This obviously requires a git and make that chances are you already have on your distro, but it also requires Node. The site is a Node site. As of today, as of December 24, we test on Node 22, but it works on other versions as well, modulo some edge case glitches. So just Google install Node 22, and there's much more than one way to install it, and I won't go into further details here. So,
the list of compilers that you will have is the...
Sorry, come again?
The list of compilers that you will have will be your own compilers?
Excellent question. That was exactly the next thing I was going to discuss. Initially, the list of compilers is rather lacking. It has what a Compiler Explorer could have found automatically. On this, this is a fresh WSL installation, and it has only GCC. It can find by itself many standard compilers, but you can download everything that the live site uses, and you can also customize it to use compilers of your own choosing. I will show at least something of this sort soon. So yes, this is not much still, this raw instance, but this is already enough for some small demo. As an example of a large-scale real-life CPP project, I cloned OpenCV, and I randomly selected one CPP file. When I just paste it to Compiler Explorer, it doesn't build, because I need at the very least to set up the include paths, but I probably should better and imitate the full compilation switch from the real command line OpenCV uses. In CMake projects, you do this rather easily. You start a verbose build. Once you do, you have the full compilation switches available to you. I copied them and I pasted them into the detailed compiler flags view. And here I have the working, the real disassembly of a full OpenCV file. You can have the same for your own real projects. Let's do something compiler explorer-y with it. I have a CFG open here.
Can it take compile commands?
Yes. Just a second, please. This is the CFG. This is the control flow graph from some random function here. This is my personal preferred way to understand this assembly. You can select whichever function you want here and use it. The full command line, as I said, is available here. It's a bit hard to work with this way, so I recommend opening the detailed compiler flags. Did I understand your question correctly?
Compile commands, JSON, whatever that are created.
Okay. The question was whether Compiler Explorer can use non-default build scripts. The answer in general is no. We support CMake files, and invocations of raw compilers with user-supplied switches. But we accept PRs all the time, plenty of them.
Very general question.
Sorry?
General question.
Yes?
I guess seeing the assembly is very helpful if you want to know what the compiler will do with some undefined behavior and glitches.
Yes.
What else do you do with watching the assembly?
The question was, what do you do with this assembly? I actually assumed that since virtually all hands were raised, that people in this audience are already interested in exploring this assembly. You don't have to. You can live your life, a very full and rich and fulfilling life, without ever inspecting this assembly. There are several cases. A very popular one is if you're a compiler developer or library developer. In my current job in Speed Data, and actually in my previous job, I raised local instances because we had a custom backend in Speed Data for our custom chip, and I use this to inspect and debug code generation problems. Before that, I worked at an HFT firm where we cared deeply about optimization, also micro-optimizations, and the impact of code modifications on the generated assembly. And we used our own in-house instance of Compiler Explorer as well. But certainly, if your interest is in the language level and does some construct build or not, you can do without the assembly. You can just type your code and see if it compiles. That's perfectly fine. By the way, Compiler Explorer is by no means limited to C++. There are currently about 60 language supported. Not all of them compile to native code. Not all of them compile to assembly. We enable interactive exploration of Python or Java to the respective bytecodes and many other features. Does that answer your question? Yes.
Just to add to the answer, some bugs you can understand only by looking at the assembly. Just a recent one, when I debugged something that ran without optimization, after optimization crashed with no reason, and only looking at the assembly, I understood it was because of using a SIMD instruction on misaligned data. Just an example.
Yes. Let me repeat that for the microphone. Another use case is debugging, when suddenly turning on optimizations cause crashes that are not reproducible in unoptimized, in debug builds. Inspecting assembly with or without Compiler Explorer can be very beneficial. Okay, so I did lie a bit. I made a small lie during this demo. Even after fixing the compile switches, this doesn't build out of the box. Compiler Explorer by default has a compilation timeout of 20 seconds. So one of the first things I do when I raise a local instance, and I go and configure it. I just added the 0 to some place, and the compile timeout on this instance is 200 seconds. Let me say at least a few words about configuration. If you have a local clone of Compiler Explorer, all configuration files are under etc config. These are .properties files. Let me call out some keys of interest. I usually turn off third-party integration and check out also status tracking enabled, especially if you have IP concerns and you don't want to allow your code to leak out in any way. This turns off Sentry reporting that sends crash info to our servers for debugging, And this turns off some buttons, particularly these buttons, CPP Insights and Quick Bench, that we have integration with. This just sends the code you type to other exploratory C++ sites. Another thing you can do, as I briefly mentioned earlier, is you can customize the heck out of the compilers. These are customizations specific to Clang 19.1. You can add your own compiler, have it run from a path of your choosing. If, for instance, you're always building with a fixed set of switches, you can fix them here and not having to retype or repaste them on every compilation, etc., etc. There's a very rich set of configurations available. Now, you can modify the existing files, but it's best practice if you don't. The files, for example, the Compiler Explorer root features, every set of configs is available as a hierarchy of files. And if you copy the file and rename it to something outside of this hierarchy, the keys in the new file will take precedence over all the existing files. This way you can also source control your modifications. Yes?
Would the local instance work with files from outside the WSA if you want to compile MSVC?
The question was, would a local instance work with files outside of WSL if you want to work with MSVC? Did I get this right? The short answer is yes, because all the Windows subsystem, the Windows file system is accessible from WSL. If you prefix the paths with /mnt/c, you could run compilers this way. You can also run Compiler Explorer directly on Windows. Yes, we actually, in the live site, we have a few Windows instances running. Typically, there are 2 of them. And it is the road less traveled. You'd have to believe me, this says Windows instances, and currently there are 3 of them. It is less tested, but it is operational. We use it all the time. We also communicate between, never mind that. Okay, I don't have time to start a new topic, so let me sum up by saying how you can reach us. Of course, you can go to the GitHub page and submit pull requests or bugs. We try to be responsive to them. But by far the best way to discuss and ask and learn about Compiler Explorer is our Discord server. You have a public invitation at our GitHub page. It's a very nice community of very friendly and knowledgeable people. This is the best way to discuss everything Compiler Explorer and even more in general, assembly and compilers in general. This is where I go to learn this stuff. Okay, I won't start anything new. Thank you very much for listening, and I'll be happy to take some questions.